Welcome, Griffins, to your first video lecture on how to do a lab, right? Check it. Density lab, got it here. See it? Density lab. Background about density. You watch the video about density. It's an intrinsic value that doesn't change no matter if the sample size or the sample temperature. So I want you to come up with something right there, but along the lines of what I just said in your words, complete sentences. You're going to need the density equation and you're going to need the percent error equation, both of which are in your unit packet, both of which are in your reference tables. All right, so you're going to need to do that. Purpose of this lab is to use density to identify an unknown metal. So that's the purpose. And then the procedure, density of regularly shaped solids. We know in density we need mass and we need a volume. So for your regularly shaped solids, we're going to use a Jenga block. You are going to need its volume. So we're going to use a ruler to get its dimensions in 3 spaces. That will get you your volume. And we're going to multiply length times width times height. And then you're going to use a balance, which I left in the back that I didn't bring up. It's an electronic balance. You're going to get the mass. And then you're going to be able to calculate your volume of your block. Now, this is what I want to happen here. This object number 1, 2, 3, and 4, I don't want that to be object number 1, 2, 3, and 4. What I want is everybody in your group to do this once, do it yourself, and then average the 3 together, okay? Notice there's a deviation from what I said to what's on the paper. So that's just going to find out, I'm going to find out that way if you're listening to the words that are coming out of my mouth, okay? Now, part 2. Procedure for finding the density of the irregular shaped objects. We are going to use marbles of some sort. I don't even know what kind of marbles these are, but they're marbles. They are round spheres, right? See them? Round spheres. We cannot just use a ruler to figure out their volume. So we are going to measure by displacement. So you're going to have some volume of water in here. Make note of what your volume of water is. You're going to add 5 marbles in and find the displacement. The volume of 5 marbles then can be divided by 5 to get the volume of 1. I would not do just 1 marble just because the volume is not going to change very much, and that is not going to give you a very accurate reading. Does that make sense? So let's use 5 marbles. If you want to use 10 marbles, by all means use 10 marbles, but make note so you know how to divide out to get the volume of 1 marble. In this particular case, though, while they're dry, see if you're going to be able to watch this backwards. Mass it first. Mass it dry, then volume it, because then it's going to get wet. We don't want to put anything wet on the balance, okay? So then I'm going to be able to, I got initial volume, final volume, total volume, calculate my density, we're good. And then the last part, part 3, is my unknown solid. So I have some blocks here. Here's one. You might actually be able to guess what it is by feeling how heavy it is and looking at its color. I'm not interested in that. Not one bit. What I'm interested in is you using your ruler to find volume, use the balance to get mass, do the ratio of those 2 things to come up with density. I have included densities of 3 metals. One of your answers is going to probably be there. I want you to use your 3 trials. So if there's 2 people in your group or 3 people in your group, I want you to do it separately again, like you did the wood block. Average your answers together. Your average density, we're going to apply to these and figure out what your unknown metal is most likely to be. It's going to be the one that's closest. It will not be exact, and that's good. Okay. Then there is a FET. You don't know what a FET is yet, but that's okay. A FET is, you type in this little guy right here, this link, and I will put this on the classroom too, so it'll be easier where you don't have to type it in. You type that in, you can answer all these questions about density. You get to play with it on a simulation, which is fun. Okay, good. Then the all-important claim evidence interpretation, CEI. This is worth 40% of your grade. So you don't do the CEI, you got a 60, you don't get lab minutes, you don't get lab credit. Simple as that. This is the most important piece. And it's not that difficult. I'm going to walk you through it the first time because you haven't done it before. Identify or the identity of my unknown matter in procedure 3 was. Well, which metal did you decide this block was? Okay, after you calculated its density. Okay, you're going to write that right there. So that's your claim. The metal was. Bam. Data and evidence. Fill in the blanks. Notice these things are kind of pointing you in the right direction so that as you get comfortable, I can not put so many words in. You can start to fill these things in yourself in future labs. The measured average density of my unknown was blank. This value is closest to blank. The accepted value is blank. Calculate your percent error. Interpretation. Using the physical property of density, I am able to. Boom. What were you able to do? What was the purpose of the lab? That's what you were able to do, is fulfill the purpose of the lab. Restate it, right? The percent error was determined to be, and this means that. Okay, well, now here's where we get to think. Why on earth would the density of this metal be different than the density of the corresponding metal that it is in your reference table? Think. Density is related to the identity of material because this is in the notes. This is part of the background knowledge that we just talked about. So I want you to think a little bit as a group and come up with some good answers and fill out your lab. So you watch this video, you write in the things here that you need to do before you do the lab. You check with me or Yanar before you go and do the lab. And that's when I give you the materials, is when I check this and make sure you've watched the video and you understand what you're doing. Might even ask you a question that you have to answer, that kind of thing. So I know you're ready. And then you can do it and you'll do it safely. And to be honest with you, I think you can do this one without safety goggles too. How's that sound? Deal. All right, see you. Have fun today.